Welcome to the final part of section 5.6 where we are going to combine parallel and perpendicular lines. Before we get to that, let's do a warm-up reviewing what we did in day 2 of this section. I want you to write the equation of a line that passes through the given point and is perpendicular to the graph of our equation. So our point is 3, 2, and our equation is y equals 3x minus 2. So, we have a slope of 3. Since they gave us the equation in slope-intercept form, it's easy to pick out our slope of 3. We have our point, 3, 2, so we're going to use point-slope form. Y minus 2 equals 3 times the quantity x minus 3. Distribute your 3 to get y minus 2 equals 3x minus 9. We want this in slope-intercept form, so we're going to add 2 to both sides to get y equals 3x minus 7. Just to review, parallel lines have what kind of slopes and perpendicular lines have what kind of slopes. Hopefully you said parallel lines have the same slope and perpendicular lines have slopes that are opposite reciprocals. In today's assignment, you are going to be figuring out whether the lines are parallel to each other, perpendicular to each other, or neither. So, in order to figure out if y equals 3x plus 7 and 4x minus 3y equals 9 are parallel, perpendicular, or neither, we need to compare the slopes. This first equation, it's very easy to pick out the slope because they've given us the equation in the form slope-intercept. So we know that this slope is 3/4. This one, not so easy. We have to figure out the slope by putting this into slope-intercept form. So that's what we're going to do. We have our equation 4x minus 3y equals 9. We're going to subtract 4x from both sides. So we have negative 3y equals negative 4x plus 9. We're going to divide everything by a negative 3, and we end up with y equals 4/3 x minus 3. So, the slope of this line we said was 3/4. The slope of the second line was 4/3. These would actually be neither. In order to be parallel, remember they have to have the same slope. In order to be perpendicular, they have to be opposite reciprocals. What we have here are just reciprocals, so therefore it's a neither. They're not going to be parallel and they're not going to be perpendicular. Let's take a look at another example. We have our equations 3x plus 3y equals 12 and y minus 4 equals negative 1 times the quantity x plus 2. This is given to us in standard form, so we have to find the slope first by putting it into slope-intercept form. So we subtract 3x from both sides. We have 3y equals negative 3x plus 12. We divide everything by 3, so we have y equals negative 1x plus 4, so my slope is negative 1. Since they gave me this equation in point-slope form, it's easy to pick out my slope of negative 1. Since our slopes are equal, these two lines are parallel. So look at another example. Here we have the equation y equals negative 6x minus 8, and here's our equation negative x plus 6y equals 12. This one's in slope-intercept form, easy to pick out our slope of negative 6. This one we have to do some work. We're going to add x to both sides to get 6y equals x plus 12. Divide everything by 6, keeping in mind that there's a 1 here. So we have y equals 1/6 x plus 2. So our slope is 1/6. They're not the same, so parallels out. They are opposites. They are reciprocals, so therefore these lines are going to be perpendicular. A final example, we have y equals 4x plus 5 as our first equation, and 4x plus y equals negative 13 as our second equation. The first one's in slope-intercept form, easy to pick out our slope of 4. The second one we're going to need to get in slope-intercept form, so we add 4x to both sides. We have y equals 4x minus 13, so our slope is 4. Since our slopes are the same, these slopes are the same, so therefore these lines are parallel. Your homework assignment for tonight is on page 331, numbers 13 to 18.